Hello and welcome to the channel again. Here we will be taking the second part of this chapter, that is periodic classification of elements. Till now we have covered all the basics of this chapter and the attempts that were made to classify the elements that were present. And finally we made it to the modern periodic table, which was given by Henry Moseley, and that was based on atomic number. Now we will be taking what are the trends in the modern periodic table. We are going to study that. And among those trends, valency is the first trend that we will be studying. But firstly, we need to know what the valency is. We say that valency is the combining capacity of element. What? Combining capacity. That means कि अगर हमारे पास कोई एलिमेंट है उसकी क्या कंबाइनिंग कैपेसिटी है, वो दूसरे एलिमेंट्स के साथ कंबाइन कैसे होना चाहता है इन order to form the compounds. That is what we call valency. And this valency is determined by the number of valence electrons that are present in the outermost shell. तो ये हमको किससे पता चलता है? ये हमको इस बात से पता चलता है कि नंबर वैलेंस इलेक्ट्रॉन्स कितने हैं एक एलिमेंट में. तो वैलेंस इलेक्ट्रॉन से हमको ये पता चलता है कि व्हाट इज द वैलेंसी, एंड फ्रॉम वैलेंसी वी गेट टू नो व्हाट विल बी द कंबाइनिंग कैपेसिटी ऑफ द एलिमेंट. So we need to know the trend along the period. So on moving from left to right in a period, the valency first increases from 1 to 4 and then decreases from 4 to 0. तो पहले increase होती है along the group and then it decreases from 4 to 0. So the maximum value of valency is 4, that is at the center of the group, center of the period we can say. हमने यहाँ पे कहा कि इट इज डिटरमाइंड बाय द नंबर ऑफ वैलेंस इलेक्ट्रॉन्स, लेकिन पिछले वाले लेक्चर में हमने ये देखा था कि लेफ्ट टू राइट जब हम जाते हैं तो जो वैलेंस इलेक्ट्रॉन्स है दे इंक्रीज फ्रॉम 1 to 8. सो द मैक्सिमम नंबर ऑफ वैलेंस इलेक्ट्रॉन्स इज 8. बट हमारे पास जो वैलेंस है, वैलेंसी है एक एलिमेंट की, दैट इज मैक्सिमम एट मैक्स 4. सो रिलेट ये कैसे है, देखिए lithium has one outermost electron and this one electron determines how it will be combining with other elements. Similarly, going on, we have carbon has 4, nitrogen has 5 electrons. इसके पास 5 है, लेकिन ये 5 इलेक्ट्रॉन्स को यहाँ से देने के बजाय 3 को लेता है इस चीज के लिए. That will determine it is what? Combining capacity. So what is it is valency now? It is 3. Why? It will take 3 electrons plus these 5, it will make it as octet complete, and we will say that this has complete electronic configuration of noble gas. Similarly, oxygen has 6 electrons in its outermost shell, it takes 2, fluorine has 7, it takes 1, and neon has already 8 electrons because it is a noble gas. So the valency is determined by the outermost electrons and it increases from 1 to 4 and then decreases from 4 to 0. This was along a period. How it is changing in going down the groups. On moving from top to bottom in a group, the valency remains same because the number of valence electrons remain same. तो ये हमने पहले भी देखा था कि डाउन द ग्रुप जब हम जाते हैं तो नंबर ऑफ वैलेंस इलेक्ट्रॉन्स रिमेन सेम, नंबर ऑफ वैलेंस इलेक्ट्रॉन्स सेम रहता है. सो जब वैलेंस इलेक्ट्रॉन सेम रहा तो हम कह सकते हैं कि इट इज वैलेंसी रिमेन्स सेम. फॉर एग्जांपल, वैलेंसी ऑफ फर्स्ट ग्रुप इज 1, वैलेंसी ऑफ सेकंड ग्रुप इज 2. तो ऐसे ऐसे बढ़ के थर्ड ग्रुप फोर्थ ग्रुप तक 4 चला जाता है एंड देन इट डिक्रीजेस फ्रॉम 4 to 0 एज in case of the period. Second property that we see, that is atomic size. We will be going to see the trend in atomic size. What is atomic size? It is the radius of an atom. Atomic size gives us the radius of atom. सेंटर से, न्यूक्लियस के सेंटर से आउटर मोस्ट शेल तक कितनी डिस्टेंस है, दैट गिव्स अस द एटॉमिक साइज. It is distance between the center of nucleus and the outermost shell of an isolated atom. जब हम isolated form में इसको लेते हैं तब कहते हैं हम कि this is the atomic size. So basically what is it? It is the distance from center of nucleus to outermost shell. This is called atomic size. What is its strength? On moving from left to right in a period, atomic size decreases because nuclear charge increases. हमने पहले ही पढ़ा कि along the period जो है जो shell होती है that remains same, but the number of electrons keep on increasing, keep on adding into this shell. At max they will be 8, but they keep on adding. So more the nuclear charge, less will be the size, because ये जो इलेक्ट्रॉन्स है इनको ये न्यूक्लियस अपनी तरफ खींचता है, तो साइज जो है वो कम हो जाता है, दैट इज कॉन्ट्रैक्टेड. वी कैन सी सो द साइज ऑफ द सेकंड पीरियड एलिमेंट्स इज लिथियम हैज ग्रेटर साइज देन बेरिलियम, that has greater than boron, then carbon, then nitrogen, oxygen and fluorine. So the trend is कि size जो है that decreases along the period, decreases along the period. Similarly, we are going to see what will be the trend along the groups. The atomic size of noble gas. अब जब हम पीरियड में देखते हैं कि साइज जो है डिक्रीज हो रहा है, लेकिन एक पीरियड में सबसे बड़ा साइज जो है दैट इज ऑफ व्हाट, this. Noble gases has the largest or highest atomic size due to presence of fully filled electronic configuration or complete octet. ये हमको पता है कि noble gases में क्या complete octet है, 8 इलेक्ट्रॉन्स outermost shell में होते हैं, तो इनका जो size है they have the van der Waals radius and that is the largest. So you need to know, ये understand होना चाहिए, ये याद रखना पड़ेगा कि जो एटॉमिक साइज नोबल गैसेस का है दैट इज द लार्जेस्ट इन ए गिवन पीरियड्स. अब एक पीरियड में सबसे बड़ा जो साइज है दैट इज ऑफ व्हाट, नोबल गैसेस. नाउ what is the trend in the groups? Atomic size increases down the group because new shells are being added in spite of the increase in the nuclear charge. लेकिन जब अब हम डाउन द ग्रुप जाते हैं तो हर किसी फ्रॉम एक ग्रुप से एक कॉलम से दूसरे कॉलम तक जाते हैं, तो एक एक शेल, अगर पहले में एक थी दूसरे में 2 आ जाती है, तीसरे में 3 आ जाती है, चौथे में 4 आ जाती है, ऐसे ही एक एक शेल ऐड होती जाती है. सो दे मोर देन कंपनसेट फॉर द न्यूक्लियर चार्ज. न्यूक्लियर चार्ज भी बढ़ती है, लेकिन दीज शेल्स आर फार अवे फ्रॉम द न्यूक्लियस एंड they have less influence of this nucleus over the electrons, and hence we say that the atomic size increases on going down the group. Atomic size of first group element is lithium is less than, sodium is less than, potassium is less than, rubidium, cesium, francium and so on. ऐसे करके ये क्या, ये बढ़ता जाता है, नीचे वाले एलिमेंट का सबसे बड़ा साइज होगा. ऐसे ही 70th ग्रुप एलिमेंट्स का अगर देखें तो ऐसे. So down the group, this we can say atomic size increases. This was the second trend that we saw in this slide, that was atomic size. पहला हमने देखा था what, valency. Valency का ट्रेंड देखा, दूसरा atomic size का देखा. Third is the metallic character. How the metallic character changes along a period and along a group. Metallic character. What is metallic character? First of all, it is the tendency of an atom to lose electrons. So जब भी हम कोई एटम लेते हैं, अगर उसमें टेंडेंसी है कि वो इलेक्ट्रॉन जो उसमें है that is basically the outermost electrons or valence electrons, अगर उसमें टेंडेंसी है कि वो ये इलेक्ट्रॉन बाहर देना चाहता है, तो we say that it has metallic character. What? Metallic character. So metallic character is the tendency of atom to lose an electron in the period. जब हम period के along चलते जाते हैं from left to right, metallic character decreases. क्यों? Because a tendency to lose electron decreases due to increase in the nuclear charge. साइज में भी हमने ये ट्रेंड देखा कि लेफ्ट राइट जाते हैं तो साइज डिक्रीज हो जाता है. दैट मीन्स कि आउटर इलेक्ट्रॉन्स पे दिस न्यूक्लियस का जो इन्फ्लुएंस है दैट इज मोर देन द एलिमेंट्स दैट आर प्रेजेंट टू द लेफ्ट साइड. क्योंकि साइज डिक्रीज हो रहा है तो आउटर इलेक्ट्रॉन्स पे न्यूक्लियस का इन्फ्लुएंस ज़्यादा है, तो दे हैव they don't have that tendency to get detached from the atom. So metallic character जो है along the period that decreases. Metallic character decreases along the period. We can see, for example, metallic character of the second period elements. Lithium is metallic, beryllium is metallic, but these elements, nitrogen, oxygen, fluorine, these are what? Non-metallic elements. We will see non-metallic character in the next slide. But for now, you just see that the metallic character decreases on going from left to right in a period. Similarly, in group, metallic character when moving from top to bottom increases because the atomic size and tendency to lose electrons increase. अब जब हम down the group जाते हैं तो नीचे वाले एलिमेंट जो होते हैं दे हैव बिगर साइज देन द अपर एलिमेंट्स. बिगर साइज है तो आउटर इलेक्ट्रॉन्स पे न्यूक्लियस का इन्फ्लुएंस जो है वो कम है. दैट मीन्स कि आउटर इलेक्ट्रॉन्स पे इन्फ्लुएंस कम है तो उनमें टेंडेंसी है कि दे कैन डिटैच फ्रॉम द गिवन एटम. अब वो उधर से जा सकते हैं तो हम कह सकते हैं कि एटम की ये जो टेंडेंसी है, एटम हैज द टेंडेंसी टू लूज इलेक्ट्रॉन्स and hence it has more metallic character than the upper atoms that were present in the same group. तो हम कहते हैं कि in the group metallic character increases on going from top to bottom. For example, first group के लिए देखें lithium is less metallic than sodium is less than potassium. ऐसे ही करके down the group जब हम जाते हैं तो metallic character increases. That is the trend of metallic character. Now moving on to non-metallic character. It is tendency of atom to gain electron. It is the opposite of what metallic character is. In non-metallic character, we say that it is tendency of gaining the electrons. Since it is tendency to gain electrons, we see in the valency that when we move along the period, first element is they have tendency to lose electrons and hence they have valency of positive 1, 2, 3, 4, and then it decreases down to 4 from 3 to 1 and 0. So these elements that are present to the rightmost side, they have tendency to gain electrons rather than give out or lose electrons. Hence we say these elements are more non-metallic in character than the leftmost elements. So the elements that have more tendency to gain electrons, we say they are non-metallic in nature. In the period, along the period ongoing from left to right, non-metallic character increases because tendency to gain electrons increase due to increase in nucleus charge. तो न्यूक्लियस चार्ज पे तो वो बढ़ रहा है और टेंडेंट जो आउटर मोस्ट इलेक्ट्रॉन्स है उन पे ये न्यूक्लियस का असर ज़्यादा रहता है तो उसमें टेंडेंसी है कि वो आउटर इलेक्ट्रॉन्स जो बाहर से आए वो उन पर भी अपना इन्फ्लुएंस जमा सके. So they have the tendency to gain electrons and hence we say the rightmost elements are more non-metallic. For example, अगर देखें हम second period के ये जो elements है they are non-metallic in character and we say that on going from left to right non-metallic character increases. On moving down the group from top to bottom, non-metallic character decreases. Why? Because atomic size increases and tendency to gain electrons decrease. अब जब साइज बड़ा हो गया, आउटर इलेक्ट्रॉन्स जो अपने ही थे उसमें उन पे न्यूक्लियस का इतना इन्फ्लुएंस नहीं रहता तो जो बाहर से इलेक्ट्रॉन कोई आएगा उस पे तो होगा ही नहीं इन्फ्लुएंस. तो इसीलिए हम कहते हैं कि ऑन मूविंग डाउन द ग्रुप वी से नॉन मेटेलिक कैरेक्टर डिक्रीजेस. जितना जितना हम डाउन द ग्रुप जाएंगे उतना उतना क्या नॉन मेटेलिक कैरेक्टर डिक्रीज होता चला जाएगा. फॉर एग्जांपल दिस फ्लोरीन इज मोर नॉन मेटेलिक देन क्लोरीन, ब्रोमीन एंड iodine. So we say non-metallic character decreases on moving down the group. This was the fourth property or fourth trend that we saw in this lecture. Coming on to the fifth, what is the chemical reactivity trend? First of all, chemical reactivity क्या है? In metals, chemical reactivity of metals increases down the group because tendency to lose electrons increase. तो अगर हम मेटल्स की बात करें उनकी रिएक्टिविटी क्या होती है जब हम डाउन द ग्रुप जाते हैं फ्रॉम मेटेलिक साइड. मेटल्स आर मोस्टली ऑन द राइट साइड ऑफ द पीरियोडिक टेबल. अगर पीरियोडिक टेबल मान के चले ऐसा है तो जो राइट मोस्ट एलिमेंट्स है दे आर ऑलमोस्ट व्हाट they are metallic in character. And the leftmost elements, they are non-metallic in character, and in between there are some metalloids. They have the properties of both metals and non-metals. So in metals, the chemical reactivity of metal side which increases down the group. Why? Because they on moving down the group, there is more tendency to lose the electron. Similarly, for non-metallic side, we say that there is less chemical reactivity on moving down the group because the tendency to gain the electrons on moving down the group decreases. So chemical reactivity increases on metallic side and it decreases on non-metallic side. Metallic side and non-metallic side. This was the trend of chemical reactivity. For that, you need to know what is the trend of metallic character and non-metallic character. Coming on to the sixth, that is electronegativity. What is electronegativity? It is the tendency of elements to attract the shared pair of electrons towards it in covalently bonded molecule. Now, what is covalent bond? Covalent bond is that type of bond in which the bond is formed by sharing of electrons. Electrons are just shared. They are not detached from the shells. So this sharing of electrons gives rise to the bond which is known as covalent bond. And when there is covalent bond between two elements and which our element has more tendency to attract the shared pair towards itself. If, for example, this is element A, this is B, and there is a covalent bond between two, and element B has more tendency in attracting these electrons towards itself. We say that the element B is more electronegative. Similarly, A is less electronegativity negative than B, and A has less electronegativity than B. It increases with increase of nuclear charge or decrease in atomic size. अब इलेक्ट्रोनेगेटिविटी के लिए हमको दो ट्रेंड देखने पड़ेंगे, या तो इंक्रीज हो रहा है क्या न्यूक्लियर चार्ज इंक्रीज हो रही है या डिक्रीज इन एटॉमिक साइज, एंड वी बोथ सी दीज वायर जब हम along the period जाते हैं from left to right, we see that the atomic size decreases and also the nuclear charge increases. Nuclear charge भी increase हो रही है और atomic size भी decrease हो रहा है. So the elements to the right must be more electronegative than the elements that are to the left. They should be least electronegative. So the trend is along the period electronegativity increases. Why? Because the atomic size decreases and also the nuclear charge increases. So along the period it increases. Like lithium is less electronegative than boron. Beryllium is less than boron. Boron is less electronegative than carbon. Carbon is less electronegative than nitrogen and oxygen and fluorine and so on. So the trend is that the electronegativity increases on moving from left to right along a period. On moving down the group, electronegativity decreases. Why? Because the atomic size increases. Atomic size increases. This has more influence than nuclear charge. So we say atomic size increases, hence what? Electronegativity decreases on moving from top to bottom along a group. This is the trend of electronegativity. And what is basically electronegativity? It is tendency of an element to attract the shared pair of electrons towards it in covalently bonded molecule. So for the trend of electronegativity, we need to first understand what was the this concept of electronegativity. It is the tendency of an element to attract the shared pair of electrons in a covalently bonded molecule. So that, and the trend is along the period it increases due to decrease in size or increase in nuclear charge, and down the group electronegativity decreases because the atomic size is increasing. This was the sixth trend of electronegativity. Coming on to the seventh trend, that is nature of oxides. Already we know that metal oxides are basic in nature and non-metallic oxides are acidic in nature. Like for example, Na2O, MgO, these are metallic oxides and they are what? They are basic in nature. And similarly, non-metallic oxides are acidic in nature. For example, Cl2O7, SO3, P2O5, these are all non-metallic oxides and they are all acidic in nature. And these are basic. In case of metal reactivity, it increases down the group because of the tendency to lose electrons. तो हमने देखा कि डाउन द ग्रुप जाते हैं तो मेटेलिक कैरेक्टर इंक्रीज होता है एंड इन केस ऑफ नॉन मेटल रिएक्टिविटी हमने देखा कि डाउन द ग्रुप जाते हैं तो नॉन मेटेलिक कैरेक्टर डिक्रीज होता है क्योंकि टेंडेंसी टू गेन इलेक्ट्रॉन्स कम होती है. तो जब हम देखते हैं एलिमेंट्स टू द राइट are non-metallic, hence their oxides are what? Acidic in nature. And elements to the left are metallic, and hence these oxides are basic in nature. This is the property of basic and acidic nature of oxides of metals and non-metals. So these were the trends that we needed to study in this module. They were, first of all, we saw what was the trend of valency. What was the trend of valency? Similarly, we saw what was the trend of electronegativity, atomic size, metallic and non-metallic character, reactivity, and nature of oxides, and so on. And in first part we had already discussed in detail the properties and all the attempts that were made to classify the elements. That is all in this chapter. होप कि आपको समझ आ गया होगा अच्छे से और आपने हमारे जितने भी वीडियो आज तक आए वो सारे देखे होंगे. सो थैंक यू फॉर ऑल. थैंक यू ऑल. आप सब हमारे इन वीडियोस पे इतना टाइम दे रहे हैं, शुक्रिया इसके लिए और आगे भी देते रहेंगे. वी विल बी होपिंग फॉर दैट. और काइंडली फील फ्री टू, अगर आप हमें कहीं पे फीडबैक देना चाहते हैं एंड ऑल दैट you can. Thank you all. We'll see you in the next module of your Athwaas series. Till then, take care.